everyone, Plus2 here. We are doing Scholarship Calculus 2024, question 1C today. A landscaper is building steps up one side of a 24-meter high hill. The slope of this side of the hill can be modeled by the curve like this, where both x and y are in meters and k is a constant to be determined. Building regulations state that each step needs to have minimum depth of 280 mil and a maximum height of 190 mil as shown. If the landscaper chooses to build each step with a depth of 280 mil, would the steps all satisfy the maximum height regulations? You must use calculus to support your answer. Right. It seems like a straightforward question, but it's not. It's quite a challenging question here. So obviously we have to find the k, right? So what it says is the height here is 48, right? And we have to find that moment. So obviously we have to differentiate this function to determine when x happens. So the turning point. So because it's negative cubic, so I assume that it's like a local minimum and local maximum, right? So we have to find the x value of local maximum. Once you do that, so plug 48 into y to find k. Once you find the k, that's yeah, so that's a step one. And step two would be we have to apply this constraint, right? Regulations. All right, so let's start with the step one. So as I said, let's differentiate. So u equals kx squared, b equals 126 minus x. So u prime is 2kx, b prime is minus 1. So I solved it earlier. So dy dx or y prime equals 252kx minus 3kx squared, I believe. All right. So set this one 0. So because k is a constant, we can divide by k on both sides. Leaves x 252 minus 3x equals 0. So either x is 0, which is here, and the other point, so 3x equals 252, hence x is 84, isn't it? So x is 84, and y is, the height is 48. Now what? Find k. So as I said earlier, you just plug 84 into x and 48 into y. So 84 squared k was 126 minus 84. Should be 48, right? And then it turns out k is it's quite a long number. I believe I found here. K is approximately 0.00162. Okay, so the equation now is y equals 0.00162 x squared 126 minus x. All right. So we formed that cubic equation. Now we have to think of this gradient, right? And then we plug that into this gradient function. So what I'm saying is, so gradient of each step is actually 19 over 28, isn't it? So when I plug k value into this gradient function, which is, I have to calculate this, 252 times 0.000162. So I'm using this, minus 3 times 0.000162 x squared. That's graded function. Is there any point it's greater than 19/28, isn't it? So that's a problem, isn't it? If it's greater than that gradient, well, that breaches the regulation, which is not good. So if it doesn't happen, which is good, it's lower enough to be safe. But if it's greater any point, then we have to sort it out. He has to sort it out. So if I simplify this, I get 0.04x minus 0.0000486x squared is greater than 0.0667. So I used graphics calculator to solve this. So if I write it again, minus 0.00486a squared plus 0.04x minus 0.67 should be greater than 0, right? So it's an upside down parabola, so would look like this. And unfortunately, there was x-intercepts. So it was, I believe, 23.4 and 58.9. So above is here, isn't it? Between these distance. So when x is 23.4 and 58.9, the slope is too high. So I'm gonna double check whether this is right. So menu, equation, right. Yes, it is right. So when distances x is between 23.4 and 58.9 meters, the slope of the steps too high should be the answer. Okay. All right. It wasn't an easy question, but I managed it. All right. I'll see you next time. Bye.